Now you are going to see Miss Thorne doing the terrible thing of writing on the book, but you then see me erase it immediately because this is one of those erasable pens. By the way, guys, if you're one of those people who hates pencil, loves pens, get yourself the erasable pens to work your math in. It is a miracle being able to erase. It really is. Save you so much work. Okay, so midpoints and segment bisectors is the first thing that gets talked about in section 1.3. So a midpoint kind of is exactly what it says. It's a point that's in the middle. So this point right here, M, is the midpoint of AB because AM is equal to MB. These two pieces are congruent and they're collinear, they're in a line, so this is the midpoint. This is how you say it, where this is the things being congruent and this is the measures being equal. The only difference between a midpoint and a segment bisector is a segment bisector is a thing that goes through that has the point. So this whole line is bisecting the segment at this point M. Here we just have a point. So if you're given, let me move my camera down here. There we go. Yeah, it's good. Oh, sorry about the wiggling. So if it's a midpoint, you can find measures, right? Because like here they said TY was 39.9, so TY is 39.9. That means this is 39.9. We add those two together, the whole thing is 79.8. We could do the same kind of thing here if we needed to find PQ, and this is 1 7/8. So the whole thing is 2 14/8, which we would then turn into a proper fraction. Same deal here. If they gave us one piece, we'd know this is also 2 2/7. So we'd add them together, we get 4 4/7. Easy peasy. Erase and easy. It makes a noise. It makes my desk shake when I erase. Now, let me turn the camera so you can see the second page. I'm going to move this up a little bit. There we go. All right. So using algebra with segment links, this is the kind of thing I'm going to test you on. Notice if these two are equal to each other, make the equation, right? Let's see. That seems, hold on a second, let me get that a little closer. That seems hard to see. Hello, fingers. That's a little better. Great. There we go. Let it focus. Okay. So this is how they got that equation. The two are equal to each other. They subtracted 3x from both sides, etc., etc. Then notice there's two steps here. This figured out what x was, but that wasn't actually what they were asking. What they wanted to know was the length of VM. Well, VM is 4x minus 1, so they take 4x minus 1 and put the answer of what x was in there, 4 times 4 minus 1, and that's where they got the 15. This construction thing will be, that you see here, you'll be doing an online version of that in your constructions. Okay. The midpoint formula. The midpoint formula. Well, I wish I could focus this thing. I might have to get a better camera. So the midpoint formula, what it does is it takes the x's from the 2 points. See these 2 points right here? They're calling it x1, y1, and this one x2, y2. You take the 2 x's, add them together, and divide by 2. That gives you the coordinate of the midpoint. It's in between the 2 x's, and the y coordinate of the midpoint is in between the 2 y's. It's an average. When you add two things together and divide by 2, you're getting the average. So that's what they're just doing. They're averaging the 2 x's. They're averaging the 2 y's. So here's an example. They took these 2 points here. The x the x's are 1 and 4, so 1 plus 4 divided by 2 made that. The y's, I have 2 and negative 3, so 2 plus negative 3 made negative 1, so that's why this is negative 1/2. You can't avoid getting fractions in the answer here sometimes. But if the points don't have fractions in it, the worst kind of fraction you'll have to deal with is a half. That's as bad as it can get. Now, there's a weird little trick that happens what if they give you one of the endpoints and the midpoint, and we need to figure out what the other endpoint is. So what they did is they're taking the midpoint formula, it's the 2 x's, but instead of where it was up here where we had 4 plus 1, here we're going 1 plus x divided by 2 makes 2. You solve for x. Same thing with the y's, 4 plus y divided by 2. And then they solved, they got y is negative 2, so that's the coordinates of the point. The third thing is the distance formula. The distance formula, now this looks crazy hard, it's not. Really what we're doing is we're using the Pythagorean Theorem. You might have gotten to use this in your algebra class or your pre-algebra class. To find this length right here, it's this length squared, that a squared plus b squared equals c squared. Well, this distance right here is c, right? So we want to know what c is, not c squared. That's why the square root sign is on it. So let me erase here before I forget. I'm going to work the example that they had here in the book. They have the 2 points, 2, 3, and 4, negative 1. I got that? Yes. Okay. So here's the distance formula. There's the difference between the 2 x's squared plus the difference between the 2 y's squared. So 2 minus 4 squared. It doesn't matter what order. I could have gone 2 minus 4 or 4 minus 2 because when I square it, it'll get rid of the negative. 3 minus negative 1. Be careful here. Yeah, that's 2 negatives in a row because we're really asking the distance between 3 and negative 1. The distance between 3 and negative 1 is 4, right? So this is 4 squared. This is negative 2 squared, and the whole thing is square rooted. So then I get 4 plus 16, so that's the square root of 20, just like that. Now, allow me to lay it. Then that would be approximately, use a calculator to get that, 4.5. I know this makes sense because I know that the square root of 16 is 4 and the square root of 25 is 5, so 20 is between these two, right? So that's why the square root, this is an approximation, approximately 4.5. It makes sense that the square root of 20 would be a number between 4 and 5.